Good morning children. We proceed on to exercise 7.2 problems based on properties of determinants. The very first idea, whenever I want to arrive at 0, try to bring two rows or two columns to be identical. Looking at the problem, I have secant square tan square in both the rows. We remember the identity secant square theta minus tan square theta equals to 1. So, LHS as I copy secant square theta tan square theta 1, tan square theta secant square theta minus 1, 38, 36, 2. To use this identity, let me write new column 1 is column 1 minus column 2. So, I am subtracting secant square theta minus tan square theta. Here, tan square theta minus secant square theta. Here, 38 minus 36. Second column, let us copy as it is. Third column also we can copy as it is. Using the identity secant square minus tan square is 1. It becomes 1. The second term minus 1. 38 minus 36 is 2. Write the remaining columns as it is. As I check, column 1 and column 3 are identical, giving a 0, which is the RHS. Question number 6, prove that. Again, when I look at the question with RHS to be 0, I check whether any rows or columns are identical. No. So, we must try to bring identical. See XX, YY, ZZ. If I subtract, that XYZ will go off. Here 2A, here A, 2B, B, 2C, C. So, if I subtract, it will help me. So, what do I do? New R1, new row 1 is row 1 minus row 2 minus row 3. What is row 1 actually? X plus 2A minus X minus A. Same way, Y plus 2B minus Y minus B. Same way, the third one, Z plus 2C minus Z minus C. Copy the next two rows as it is. Now, look at R1. X and X cancels. 2A minus A gives me A. Y and Y cancels. 2B minus B is B. Z and Z cancels. 2C minus C is C. Second and third rows we just copy down. As I look at the determinant, R1 and R3 are identical. Whenever two rows are identical, the answer is 0 and 0 is the RHS. Question number 7. Write the general form of a 3 by 3 skew symmetric matrix and prove that its determinant is 0. We know A minus A transpose is a skew symmetric matrix because A minus A transpose is minus of A minus A transpose the whole transpose. Considering the general matrix as A, we have written the transpose and we have written A minus A transpose. As I see, diagonally it is 0. So, I have 0, 0, 0. If I put B1 minus A2 as X, here I have the reverse A2 minus B1, so it is minus X. If I put C1 minus A3 as Y, here I have A3 minus C1, so it is minus Y. Putting C2 minus B3 as Z, we have B3 minus C2, so it is minus Z. To get the determinant of 0xy minus x 0z minus y minus z 0, Remember how to expand the determinant. We put plus symbol, minus symbol, plus symbol. Remember 0 into anything 0, forget it. You have minus x into, hide the row, hide the column. I am left with minus x, z, minus y, 0. Plus y into, here y is coming, so hide the row, hide the column. I am left with minus x, 0, minus y, minus z. As we expand, multiply, multiply and subtract. Minus x into 0, minus y into z. Plus y into minus x into minus z plus xz. 0 into any number 0. We get minus into minus into minus, minus x into y into z, x, y, z. Plus y into xz. Same term, plus and minus gets cancelled, so my answer is 0. The question is to show that the determinant of a general 3 by 3 skew symmetric matrix is 0. We have obtained a skew symmetric matrix and we have proved the determinant to be 0. So let us remember how a skew symmetric matrix of 3 by 3 order will be. You have diagonally zeros. You have xn minus x, yn minus y, zn minus z. So any matrix of this pattern, here and here same but different sign, here and here same but different signs, here and here same but different signs. Diagonally zeros are coming. If this is of the pattern, we call it is a skew symmetric matrix. Question number 8. If the given determinant is 0, prove that A, B, C are in GP or alpha is a root of ax square plus 2bx plus c equal to 0. What do you mean by alpha is a root of this? This gives me the clue as to what I must do with a determinant. If I say alpha is a root, wherever x comes, I have to put alpha. A alpha square plus 2b alpha plus c equals to 0. In the first row, I have a alpha, but I want a alpha square. So what we do? LHS, I am writing R1 into alpha. So what happens? A alpha, B alpha, A alpha square plus B alpha. Second and third row just copy as it is. This is equal to alpha into 0 because I am multiplying both the sides by alpha. The next step. I want plus C also. So add R1 becomes R1 plus R2. So what I get? A alpha plus B. B alpha plus C. These two when I add, A alpha square plus B alpha plus B alpha plus C. This is equal to 0. Second and third row we copy as it is. Now as I look out, first row and third row, A alpha plus B, B alpha plus C and some other terms are there. So let me subtract. New R1 becomes R1 minus R3. A alpha plus B, A alpha plus B. As I subtract, I get 0. B alpha plus C, B alpha plus C. Subtraction gives me 0. Subtracting 0, we get the same term. A alpha square plus 2B alpha plus C. Minus 0, so I need not write it. RHS 0, we just maintain as it is. P, C, B alpha plus C. A alpha plus B, B alpha plus C, 0. Now we shall expand the determinant. first row symbols plus, minus, plus. So as we expand along the first row, I get, see, here 0, here 0, 0 into anything, 0 into anything, 0. I am just left with this term, A alpha square plus 2B alpha plus C into, hide the row, hide the column. I am left with these two rows, B, C, A alpha plus B, B alpha plus C, and the RHS is 0. As I expand, A alpha square plus 2B alpha plus C into B into B alpha, B square alpha, B into C, BC, minus A alpha into C plus BC. As I expand, A alpha square plus 2B alpha plus C into B square alpha plus BC, I can cancel because there is minus symbol. Minus AC alpha, this is equal to 0. Given RHS is 0. So I get either A alpha square plus 2B alpha plus C is 0 or B square minus AC into alpha is 0. This implies alpha is a root of this equation. AX square plus 2BX plus C equal to 0. This implies B square minus AC is 0 or A, B, C are in GP. Let us remember, if A, B, C are in GP, B square equals to AC or B square minus AC is 0. So the two brackets, the RHS 0 tells me put each bracket separately 0. Either the first bracket 0 or the second bracket 0. First bracket gives us the idea alpha is a root of A. Wherever alpha comes, you write X. So that will become an equation. Alpha is a root of this equation. Or B square minus AC 0 tells me A, B, C are in GP. Hence the problem. Question number 15. Without expanding, evaluate the determinant 2, 3, 4, 5, 6, 8, 6x, 9x, 12x. As I look at the third row, 6, 9, 12. In all these numbers, 3 is common. Also, x is common. So, taking 3x from third row, I am left with first row as it is, second row as it is, third row. 6x, I am taking 3x, so it is 2. From 9x, if I remove 3x, it is 3. 12x by 3x, it is 4. Row 1 and row 3 are identical. So we get 3x into 0 and the answer is 0. Second subdivision, x plus y, y plus z, z plus x. Second row z, x, y and third row 1, 1, 1. To evaluate without expanding, we can check whether any two rows are identical. No. Is anything common? No. So, try to make something as common. Here x and y are there, z is missing. If I add, this becomes x plus y plus z. This also becomes x plus y plus z. And this also becomes x plus y plus z. So, new R1 is R1 plus R2. So, what is my answer? X plus y plus z. Second also x plus y plus z. Third also x plus y plus z. As I see, x plus y plus z is common in row 1. X plus y plus z into first row. As I take x plus y plus z common, it becomes 1, 1, 1. Second row zxy, third row 1, 1, 1. As I look out, R1 and R3 are identical. Immediately, the determinant vanishes. So 0 into x plus y plus z is also 0, and that is the answer. Question number 9. Prove that 1a square minus bc, 1b b square minus ca, 1c c square minus ab equal to 0. As I look at LHS, third column is a sum of two elements. So the determinant itself becomes sum of two determinants. First column we write the same. Second column we write the same. Third column, all the first elements we write in the first determinant. All the second elements we write in the second determinant. Now this I copy as it is. I try to bring this determinant like this. To bring that, in the third column minus is common, take minus out. The next step, whenever I have A, B, B, C, C, A, whatever letter is missing, let me multiply. In R1, A is missing. R1 multiplied by A. In R2, B is missing. In R3, C is missing. And whenever I multiply, I must also divide by ABC. As I write it, first determinant I copy as it is. Second determinant, there is minus symbol, we divide by ABC. First row, multiplying by A, 1 into A into A into BC. Second row by B, 1 into B into B into AC. Third row by C, 1 into C into C, ABC. Now, in third column, ABC is common. So, first determinant write as it is. In the second determinant, take ABC from column 3. We are left with ABC, A square, B square, C square. As I take ABC out, they all become 1. This ABC I can cancel. This and this to have in the same pattern. Check. I need ones in the first column. Write the first determinant as it is. Interchange column 1 and column 3. Whenever I interchange two columns, minus symbol will become plus. So first determinant, no change. Second determinant, I write first column as third. Second column, no change. Third column as first. Are they one and the same? No. Again, I want ABC in the middle. So, interchange column 2 and column 3. Whenever I interchange two columns, sign changes. Plus becomes minus. First column as it is. Second column is ABC. Third column is A square, B square, C square. They are one and the same, but there is minus symbol in the middle, so that gives me 0. And 0 is the RHS. We are using very many properties of determinants in this particular problem. First, there are two elements. I split the two determinants. All the first elements in first, all the second in second. So this is one property. Second, in a particular column, a number is common, I can bring it out. Here minus sign is common, I have brought out. The next property, I can multiply a row by a number. Whenever I multiply, I must also divide. So R2 by B, divide by B, R3 by C, divide by C. This division I put out. Each row we multiplied by the specified number. Now the next property, I interchange C1 and C3. Whenever I interchange any two columns, minus becomes plus, plus becomes minus because here also I am interchanging. The same determinant with minus symbol in between gives me 0, which is the RHS. Question number 10. If A, B, C are pth, qth, rth terms of an arithmetic progression, find the value of the determinant. Wherever A, B, C comes, I must write T, P, pth term, I must write B, qth term, and I must write C, that is rth term. What is arithmetic progression nth term formula? A plus n minus 1 into D, where A is the first term and D is the common difference. As I substitute this formula for P, it is A plus P minus 1 into D. Here A plus Q minus 1 into D. Here A plus R minus 1 into D. As we substitute in the given determinant, A, B, C, P, Q, R, 1, 1, 1. Wherever A comes, A plus P minus 1 into D. In the place of B, A plus Q minus 1 into D. In the place of C, A plus R minus 1 into D. Second and third row, we write as it is. As I look out, first row, there are two terms. Let us split it. All the first elements will come in the first determinant. All the second elements will come in the second determinant. As we have written, copy second and third row as it is. The next step. In this, D is common. So, I am removing D from first row. I get P minus 1, Q minus 1, R minus 1. Second row, P, Q, R. Third row, 1, 1, 1. In the first determinant, A is common. Remove A out. So, I am left with first and third row to be identical. Whenever first and third rows are identical, the first determinant will become 0. So, my answer is A into 0 plus D into. In the second determinant, I can write R2 becomes R2 minus R3. New R2 is R2 minus R3. First row, P minus 1, Q minus 1, R minus 1. Second row minus third row. It is P minus 1, Q minus 1, R minus 1. Write third row as it is. Now also R1 and R2 are identical. So I have D into 0 and my answer is 0. Question number 11. Show that the determinant is divisible by x power 4. As I call the determinant as some name, say del. As I copy down a square plus x square, ab, ac. ab, b square plus x square, bc. ac, bc, c square plus x square. First column A is there, but here A is not present. So, to ease, we are writing R1 multiplied by A, R2 multiplied by B, R3 multiplied by C and divide by ABC. So, del becomes 1 by ABC as I divide. Multiply R1, A into A square plus X square, A into B, A into AC. Second row by B, A into B square, B into B square plus X square, B into BC. Third row by C, AC into C, BC into C, C into C square plus X square. As I check, first column A is common, second column B is common, third column C is common. So we remove A from first column, B from second, C from third. I am left with A square plus X square, B square, C square. A square, B square plus X square, C square. A square, B square, C square plus X square. So we have taken C from column 3, B from column 2, A from column 1. As I check, I have A square, X square, B square, C square. Here and here the same. This A, B, C I can cancel. So we add. New R1 is R1 plus R2 plus R3. As we add R1, R2, R3, A square plus X square plus B square plus C square, the same here, the same here. A square plus B square plus C square plus X square. Copy second and third row as it is. Now, in the first row, it has the same term, so we can take A square plus B square plus C square plus X square as common. I am left with 1, 1, 1, B square plus X square, B square, C square, C square, C square plus X square. Once I get ones, it is easy for me. Column 2 becomes column 2 minus column 1. Column 3 becomes column 3 minus column 1. As I subtract, it is A square plus B square plus C square plus X square into column 1, no change, right as it is. Column 2 minus column 1. Subtract 1 minus 1. B square plus X square minus B square. C square minus C square. Column 3 minus column 1. 1 minus 1. B square minus B square. C square plus X square minus C square. As I simplify, it is A square plus B square plus C square plus X square into 1B square C square. 1 minus 1, 0. B square cancels. X square. C square minus C square, 0. Again 0, 0, X square. As I expand the determinant, 0 into anything 0. We know the symbols plus, minus, plus. But 0 into anything 0, so ignore. I am just left with A square plus B square plus C square plus X square into 1 into X square. So 1 into X power 4 minus 0. As I see this, it is divisible by X power 4 and hence the problem. The question says the determinant is divisible by X power 4. We have something into X power 4. Therefore, the given determinant is divisible by X power 4. Question number 12. If A, B, C are all positive and are pth, qth and rth terms of a GP. GP tells it is geometric progression. We want to show this determinant is 0. Given A, B, C are pth, qth, rth terms of a GP. In a geometric progression, we know nth term is A r power n minus 1. Already r is coming in the question. So instead of r, I have used k, where k is the common ratio and a being the first term. When I want TP, it is a k power p minus 1. But in the question, I want log a. When we take logarithm, remember multiplication we added a k power p minus 1. When I take log, it is log a plus log k power p minus 1 because multiplication tells addition. Then Power comes near. So P minus 1 log K. Let us use this here. So what is log A? It is log A plus P minus 1 log K. The same idea for qth term. It is A K power Q minus 1. When I am taking log A plus Q minus 1 log K. Multiplication is addition, power comes near. Rth term, it is A K power R minus 1. When I take logarithm, log A plus R minus 1 log K. As I know log A, log B, log C, let me substitute in the given determinant. As we know, every term in first column is a sum of two elements. We can split the determinant itself as sum of two determinants. In the first determinant, the first elements will come. In the second determinant, P minus 1 log K, all the second elements, Q minus 1 log K, R minus 1 log K. Now, the second and third column I copy as it is. In this, log A common in first column, as I remove, it is 1, 1, 1, PQR 1, 1, 1. As I check, column 1 identical to column 3, so log A into 0. First part is done. Coming up to second part. Here, log K is common in first column. I have P minus 1, Q minus 1, R minus 1. Second and third column write as it is. Log K let me write as it is. This and this let me add. C1 becomes C1 plus C3. As I add, P minus 1 plus 1 cancels. Q minus 1 plus 1 cancels. R minus 1 plus 1 cancels. Second and third write as it is. As I check here, first column identical to column 2. So this also becomes 0. Log A into 0, 0 plus log K into 0 and the entire answer becomes 0, which is the RHS. Question number 13, we need to find the value of the determinant when x, y, z are not equal to 1. To evaluate the determinant, let us use Sars Rule. What is Sars Rule? Let us recall. Copy the first column as it is. Copy the second column as it is. Copy the third column as it is. Then again we copy first column. 1 log x base y log x base z. Again we copy column 2. Remember how to multiply. Diagonally we put arrow mark. 1, 1, 1, the second and the third. As I multiply, 1 into 1 into 1, 1 plus log y base x, z base y, x base z plus log z base x, x base y, y base z. So the first product is over. And now I go on to the second product in this way. As I multiply, we put minus symbol. Log x base z into 1 into log z base x plus log y base z log z base y into 1 plus 1 into log x base y log y base x. As we expand, Y cancels, Z cancels, X cancels, I just get 1 plus X cancels, Y cancels, Z cancels, I just get 1. So it is 1 plus 1 plus 1 minus. Here Z and X are cancelling, I am left with 1. Z and Y are cancelling, I am left with 1. X and Y are cancelling, I am left with 1. It is 3 minus 3 and my answer is 0.